Good day, everyone. Let us try to solve this interesting number sequence problem. We will find the sum of all the number entries in a 10 by 10 multiplication table. Now, there are several ways to get the sum. The first is we have to consider the sum of each row and then add all the sum of each row. Another way of getting the sum is we try to get the sum of the entries of each column, and after that we get the sum of all the sums that we get for each column. Now let's try to get the sum of this 10 by 10 multiplication table by using the rows. So let's take the first row first and label the sum to be S1. Now as you can see, the entries in the first row are this one. So we add them up, that becomes 1 plus 2 plus 3. It goes on until 10. Now this time, let's consider the second row and label the sum as S2. Now we add all the entries in this row. We have 2 plus 4 plus 6, so on and so forth until 20. But one thing that you will notice here is that 2 is a common among all the addends for S2. So we factor out 2, that becomes 2 times 1 plus 2 plus 3, so on and so forth until 10. But this one here is just the same as S1. So we replace this one here by S1, so this will become 2 times S1. Now let's proceed to the third row and label the sum as S3. Looking at the entries, we know that the sum will be 3 plus 6 plus 9, so on and so forth until 30. Now, just like in the previous row, we notice that there is a common factor, and this time it's 3. So we rewrite this by getting the factor. We have 3 times 1 plus 2 plus 3, so on and so forth up until 10. Now again, this one is just our S1, so we replace this by S1. This will now become S3 equals 3S1. Now from the first 3 rows, we notice that the sum of each row is just equal to the number of row times S1. So by observing that pattern, we will write all the sum that way. So we have S1 up until 10S1. We add this up. This is how we're going to write it. Now, as you can see, that this sum here has a common factor that is S1. We take out S1, so that becomes S1 times 1 plus 2 plus 3 plus 4, so on and so forth up until 10. But S1 again is just 1 plus 2 plus 3 plus 4 plus 5, so on and so forth until 10. So we replace this S1 by 1 plus 2 plus 3, so on and so forth up until 10 times 1 plus 2 plus 3, so on and so forth up until 10. Now to get the sum, we can just add them conventionally. We can just add all the numbers conventionally. But for the sake of establishing a general concept without losing generality, we can do a systematic addition. Now we take 1 and 10 as a pair, and we take 2 and 9 as a pair as well. Now that means we add them by pair. Now notice that each pair will have a sum of 11. That means every other pair will also have a sum of 11. So from 1 to 10, there are actually 5 pairs. So we'll multiply the sum of each pair, which is 11, by 5 to indicate the 5 pairs. So this will be 55. So this one, since this is just the same here, then this will also have a sum of 55. Multiply them together, we have 55 times 55. That is 3025, and this is now our answer. Therefore, the sum of all the numbers in the entry of a 10 by 10 multiplication table is 3025. Now, it will be very interesting to note that by using the same procedure we did in this video, we can actually find the sum of the entries of a multiplication table of any dimension. So that's it for this video. Please don't forget to like and subscribe to our channel for more challenging algebra problems. Thank you so much. Enjoy learning.